Good evening, everyone.
Good evening, sir.
Yeah. One minute, my pen is not working. Silent. Okay. So I think there's the only topic that is left out for us to discuss, right? From electrostatics. One is that is Gauss law. Right. Shall we start that? So that is applications based on Gauss law. So yesterday we discussed the concept based on.
Sir, are you sharing your screen?
Oh, no. Is it visible now? Is it visible now?
Yes, sir.
Okay, listen. So we discussed the concept of flux, which was E vector dot A vector or EA cos theta. Then we discussed the concept of Gauss law. What did Gauss law say? Flux is equal to the surface integral of E vector dot dA vector, which is also equal to the charge enclosed divided by epsilon naught. So based on Gauss law, we have three applications. What are they? Finding the electric field due to a linear charge, then surface charge, and spherical shell. So for surface charge, we'll calculate it for a plane sheet, right? So for a linear charge, what is going to be the value of electric field? It is lambda divided by 2 pi epsilon naught r. For surface charge, the electric field is going to be sigma divided by 2 epsilon naught due to either side of the plate. And for spherical shell, E will be equal to Q divided by 4 pi epsilon naught small r square. For a point outside it, right? 0 for a point inside, and Q divided by 4 pi epsilon naught capital R square on the surface, right? I hope everybody knows these points. Am I right? So is there any doubt from this? So based on this, let's try out some problems. So first one is, mark it as important. So there are two long straight parallel wires. So in physics, whenever you see long, they are of infinite length. They're assumed to be of infinite length. So two long straight wires carry charges lambda 1 and lambda 2 per unit length. There are two parallel wires which carry the charges lambda 1 and lambda 2 per unit length. The separation between their axes is d. Find the magnitude of the force exerted on unit length of one due to the charge on the other. So if I take a unit length of this portion, okay, if I take it to be L, then I need to calculate the force divided by L of the second rod. So how do I do that? So for that, anybody who can give me an idea of how to proceed?
Or we can take Q1 as lambda 1 into L1.
Into L1.
L, sir.
Okay. So you want to take Q1 is equal to lambda 1 into L. So lambda 1 is this side. Are you right?
Yes, sir.
So you want to take a length L here. Is that what you're saying?
Yes, sir.
Okay. Okay. Now, what should I do?
Sir, just a second, sir.
I'll just give you hints, okay? I'll try to construct it. You people think and tell me. For you to
Sir.
calculate, tell me.
Sir, so just a second, 1 second. Is there any background noise?
From my side. No.
No, sir, from my side. Is there any
No,
background
no, no,
noise?
no, no background noise.
Okay, okay. Okay, sir. So basically, in the wire L1, each charge is basically mu2 into L. So each point carries a charge of mu2 into L. So there are total of L number of points. So the charge would be mu2 into L. And since there are total of L number of points, we'll square it, basically mu2 into L square. And each point experiences a electric field of 2 pi epsilon naught r. So I mean lambda upon 2 pi epsilon naught r. So that would be lambda 1 into lambda 2 into L upon 2 pi epsilon naught r. So
Okay. So what will be the final answer?
sir, lambda 1 into lambda 2 upon 2 pi epsilon naught r.
Answer is right. Can we make it slightly simple? See, what did I say is the value of electric field generated due to a linear charge? So what is the value of electric field generated due to it? lambda 1 divided by 2 pi epsilon naught into d. Can I say it like this?
Yes, sir.
Now see, second step, this amount of charge, how much is the charge? Lambda 2 into L, amount of charge is placed in the presence of electric field due to the first charge. So this is the electric field due to the first charge. And lambda 2 into L is the charge on the portion considered. Am I right? So what is going to be the force experienced by the portion? It will be equal
Charge.
to charge multiplied with electric field. The charge is how much? Lambda 2 into L into electric field is lambda 1 divided by 2 pi epsilon naught into d. This is going to be the force. But what did they ask? Did they ask us the force? They ask us the force per unit length. Means bring the L to the left hand side. So F divided by L will be equal to lambda 1 into lambda 2 divided by 2 pi epsilon naught into d. This is going to be the answer. Your answer is right. But did you understand the steps?
Yes, sir.
That's it. So this is how we solve. So whenever you have a question that is based on these kind of conductors, right, when they are placed parallel to each other, something like that, calculate the electric field due to one conductor on near the other and multiply it with the charge. That will give you the force. Is everyone clear with this? Okay. Shall I proceed?
Yes, sir.
Sir, can you explain how that equation
Which one? Huh?
F
Which
by
equation?
L equals final?
This one, huh? You have till here you understood? Till this step, are you clear?
Yes, sir.
Okay, I just brought this L to the left hand side. That's it.
Okay, sir.
So this is what is called as force per unit length. So that's what they ask. See, they ask force exerted on unit length. So unit length means not one. Force per L is what is force per unit length. Clear? And there is a similar kind of a concept in some other chapter also. Where do we do this?
Magnetism, sir.
So force experienced by two current carrying
Force between
conductors.
two parallel current carrying conductors. So what force is that? It is a magnetic force. Force experienced between two parallel current carrying conductors. So it's the same logic if you recollect, no? You will calculate the magnetic field due to one at the second point and then multiply with the value of current. So same logic. Okay. Anyways. So example 71. There is a charge of 17.7 into 10 power minus 4, which is distributed uniformly over a large sheet of area 200 meters square. So how much is the charge? 17.7 into 10 power minus 4 coulomb is distributed uniformly over a large sheet. Large means again infinite sheet of area 200 meters square. Calculate the electric field intensity at a distance of 20 centimeter from it. Answer. E is equal to
Sir, approximately 5 into 10 power 5.
so what is the formula you need to apply? Sigma by
2 epsilon.
so what is the unwanted data in this problem?
20 centimeter.
Reason?
So because in the formula, we don't need to use
We
the
don't need
distance.
it. And one more important point is due to a plane sheet, we know the fact that the electric field generated is going to be uniform, right? So E will be equal to Q divided by A by 2 epsilon naught. What is the value of Q? 17.7 into 10 power minus 4 divided by A is 200 divided by epsilon naught. So 2 into 8.85. So this is approximately 1. So it will be 0.5 into 10 power minus 6 Newton per coulomb. This is approximate value.
Sir, 8.85 into 10 power minus 12.
That 10 power minus 12 is there, no? So then this 10 power minus 12 goes to numerator, it becomes plus 6. Right? So it should be 0.5 into 10 power 6. Am I right?
Yes, sir.
Okay. Next. Try this one. A charged particle having a charge of minus 2 into 10 power minus 6 coulomb placed close to a non-conducting plate having a surface charge density of 4 into 10 power minus 6 coulomb per meter square. Find the force of attraction between the particle and the plate. Again, whenever you need to calculate the force, it is Q multiplied with E. You have charge. What is your job? Calculate the electric field due to this plane sheet. Multiply both. That will give you the answer. So what is the value of E? E is equal to sigma by 2 epsilon naught. Sigma is how much? 4 into 10 power minus 6 divided by 2 into epsilon naught is 8.85 into 10 power minus 12. So this goes 2 times. Right? So once you get the value of electric field, multiply with whom? With the magnitude of this charge. Okay, because they use the word force of attraction. So you're not concerned about minus sign. So F will be equal to how much? 2 into 10 power minus 6 into 2 into 10 power minus 6 divided by 8.85 into 10 power minus 12. Is this point clear? So when you calculate it, you should get the answer as 0.45 Newton. Is there any doubt? I hope you understood the
No, sir.
logic.
No, sir.
So we'll do one last problem based on Gauss law, and then we'll move on to the next chapter. A large plane sheet of charge having surface charge density of 5 into 10 power minus 16 coulomb per meter square. So sigma is equal to 5 into 10 power minus 16 coulomb per meter square lies in the XY plane. Find the electric flux through a circular area of radius 0.1 meter if the normal to the circular coil makes an angle 60 degree with the z-axis. So theta is equal to 60 degree. So what is the value of epsilon not given? It is 8.85 into 10 power minus 12. So if you read the question, you will understand. So the problem is based on flux. So flux is equal to what? E vector dot A vector. So what is the value of E vector? How will you calculate E vector?
Sigma by 2 epsilon naught.
So sigma by 2 epsilon naught. Sigma is given 5 into 10 power minus 16 divided by 2 into 8.85 into 10 power minus 12. Right? When you multiply this and calculate it, you will get the value of electric field. Once you get the value of electric field, plug it here. So actually, what is going to be the formula? E into A into cos theta. Right? So E is how much? This value. So for area, you will take pi r square into cos of how much should I write? Should I write 60 or 30?
60.
I'll write it as 60 only because read the question carefully. They told that this plane sheet is lying in the xy plane. So what is going to be the direction of its aerial vector?
Z axis. Sir.
Z-axis. So what is the angle made by the circular? What is the angle made by the electric field with the Z-axis? It is 60. Okay. So I hope that part you can calculate. So solution is here. This is going to be the answer. Okay. So with this, we are done with electrostatics. I mean, electric charges and fields. Shall we get started with the next chapter?
Yes, sir.
So that is electrostatic potential and the capacitance. Okay. So here, if you see, what is going to be the potential difference? It is defined as the amount of work done per unit charge, right? So how do you calculate the electrostatic potential due to a point charge at a distance r? So V will be equal to Q divided by 4 pi epsilon naught into R.
Sir,
So if you
can I
have a
see what you're writing, sir?
screen is not visible.
Yes, sir.
What is happening? Just give me a minute. No. Complete. Now is it visible? Now is it visible?
Yes, sir.
Okay. So how to calculate the potential due to a point charge at a given point? It is going to be Q divided by 4 pi epsilon naught into R.
Sir,
Right? Tell me. Sir.
sir, it's too small.
Screen
It's
is
too
too
small.
small, sir.
No?
Yes, sir.
Yes,
Yes,
sir.
sir.
Now,
So it is going to be Q divided by 4 pi epsilon naught R. And remember that the electrostatic potential is a scalar quantity. Suppose you have n charges present, n point charges present in a system, then what is going to be the electrostatic potential due to all the charges put together? It will be the sum of the potential due to individual charges, right? Similarly, what is going to be the potential due to a dipole at axial point? Anybody? At axial point, what is going to be the potential? I'm talking only about magnitude. P divided by 4 pi epsilon naught R square. Okay. So I think most of you are not confident with this electrostatic potential due to a dipole. See, if this is plus charge, this is minus charge. If I want to calculate the potential at point P, how should I apply? This is Q, and the distance of separation between them is 2a. So where is the distance with respect to a dipole measured from? It is always measured from the center. So if you break the dipole into two equal parts, A and A, so from the center, if I take this point to be at a distance R, then how much will this value be?
R minus A.
R minus A. Then how much is this value going to be? It is going to be R plus A, right? Now, if I take this as A and B, what is the potential at point P due to A? It is going to be Q divided by 4 pi epsilon naught into R minus A, correct? So what is the potential due to B at point P? Q divided by 4 pi epsilon naught into R plus A. There is a mistake in that equation, correct it.
So the minus sign should apply.
You
in
need to put the minus sign. Why? Because you're dealing with a
scalar value.
Scalar.
scalar quantity. Whenever you're dealing with scalar quantity, sign of the charge should be applied in the formula. Okay. So total potential is equal to VA plus VB. So it will be Q divided by 4 pi epsilon naught into 1 divided by R minus A plus 1 divided by R plus A. But here you have a minus sign. Is that clear? So what will you do next? Q divided by 4 pi epsilon naught into You will take LCM. When you take LCM, R plus A minus of R minus A divided by R square minus A square. R and R will get cancelled. What will you have? You will have 2A into Q divided by 4 pi epsilon naught into R square minus A square. So with respect to a dipole, R square minus A square is always approximated to
R square.
R square. So what is this 2A into Q?
Dipole moment.
So P divided by 4 pi epsilon naught R square. Am I right?
Yes, sir.
That's the answer. Okay. Suppose you want to calculate the same potential due to a dipole at equatorial point. What is the answer?
0, sir.
0. Right. Next. Potential due to a dipole at any point, right, which is making where the radial line is making an angle theta with respect to the axis. Suppose I have a dipole like this. Okay, I have a point P here. If this is going to be, I'm sorry. If this is going to be the point P, if I take this distance to be R and if I take this to be theta, then what is going to be the dipole moment? It is going to be P cos theta divided by 4 pi epsilon naught into small r square. That's it. Right. So what is the other way of writing it? It is P vector dot R vector divided by 4 pi epsilon naught R cube. Okay.
Sir,
Tell me, Pa.
if we write like instead of R vector, R cap is used, then denominator should be R square, right?
R square. Good. So if it is 1 by 4 pi epsilon, I'll use another color. This question is 1 by 4 pi epsilon naught. If I use P vector dot R cap, then what should have been the denominator? The denominator would have been R square. Whereas if I write 1 by 4 pi epsilon naught into P vector dot R vector, then the denominator will be R cube. Are you able to understand? Is the difference clear to everyone? Unit vector, denominator is square. The vector itself, denominator is cube. So please be careful. If this comes in a 1 mark question, where they give you 4 options and ask you to choose the right one, you need to have this clarity. Am I clear with this? Is there any point that you want to make a note from the slide? If you're clear, please give me a confirmation so that I'll proceed.
Yes, sir.
Okay.
Yes, sir.
Yes, sir.
Is there anything you want to make a note from this slide?
No, sir.
So can I erase it? I'm going to completely erase it. Can I?
Yes, sir.
Okay. Shall we try the first problem? So I want you all to read the question. 100 joule of work is done in. So work done is equal to 100 joule. Has to be done in moving an electric charge of how much? I think there is a mistake here. Okay. As of now, I'll make it as 4 coulomb. Okay. I want to move a charge of 4 coulomb from a place where the potential is minus 10 volt to another place where the potential is V volt. What is the value of V? So what is work done is equal to? If you go back to the previous slide, potential difference is work done by Q. So what will work done be? Work done will be equal to Q into V. So can I say work done is equal to the charge multiplied with V2 minus V1? Why did I write it like this? Charge multiplied with final potential minus initial potential. So what is the value of work done? It is going to be 100 is equal to 4 into what is the value of V2? That is V, which we need to calculate, minus what is the value of V1? It is minus 10. So this will get cancelled 25 times. Is that clear? So 25 is equal to V plus 10, which implies V will be equal to 15 volt. Am I clear? So I don't know. 4 coulomb only, correct only. So the potential, the final potential is going to be equal to 15 volt. Is that right? Shall I proceed?
Yes, sir.
Determine the electric potential at the surface of a gold nucleus, right? The radius is 6.6 into 10 power minus 15 meter and atomic number is 79. Given charge on the proton is equal to 1.6 into 10 power minus 19 coulomb. So what will be the answer? So if I take this to be the nucleus, okay, listen to this carefully. If I take this to be the nucleus, then where are they asking the potential? At a point P on the surface. So what shape does a nucleus take? It takes the shape of a sphere. Now tell me, what is the electrostatic potential due to a charge inside on the surface of the conductor?
Constant.
It's a constant. So what is going to be the value? So potential at point P, can I say it is going to be Q divided by 4 pi epsilon naught into R? Can I? Where Q is going to be the amount of charge that is present inside the nucleus. Now recollect the concept. Who is responsible for the nuclear charge? Who takes care of the charge of a nucleus? It is protons. Am I right? Now the next question that we need to answer is, how many protons are there inside this nucleus and what is going to be the charge inside it? So Q is equal to N into E. So N is 79 into what is the charge of each proton? It is going to be 1.6 into 10 power minus 19 coulomb. So what is going to be the potential here? That is 79 into 1.6 into 10 power minus 19 into 9 into 10 power 9 divided by R. What is the value of R? It is 6.6 into 10 power minus 15. Is this point clear to everyone? Did you understand how to calculate the potential due to a sphere?
Yes, sir.
Yes, sir.
So it will come out to be a certain value. And this calculation part, I'm leaving it to you.
Sir, is it 1.72 into 10 power 8?
1.72 into 10 power 7 is what is given here.
Oh, yes, sir. 7 minutes.
To 10 power 7 volt. Okay. Next. Example 3. Calculate the potential at a point due to a charge 4 into 10 power minus 7 coulomb, which is located 9 centimeter away from it. So I need to calculate the potential at this point. So can you tell me what is the answer? So what is the potential due to the charge at point P? Q divided by 4 pi epsilon naught R. So what is the value of Q? It is 4 into 10 power minus 7 into 9 into 10 power 9 divided by R is how much? 9 into 10 power minus 2. So 9 and 9 will get cancelled. 4 into 10 power 2 into 10 power 2. So it is going to be 4 into 10 power 4 volt. Am I clear with this point? So basically 40,000 volt. Now, obtain the work done in bringing a charge of 2 into 10 power minus 9 coulomb from infinity to a point. So what is going to be the answer? Work done is equal to
8 into 10 power minus 6.
that you tried to bring in multiplied with the potential at that point. See, I would like to explain one point. Listen to this carefully. Whenever you have a charge and you want to calculate the force experienced by the charge due to electric field, then you will apply the formula F is equal to QE. So instead of electric field, if you know the potential at a point and you multiply with the charge that you're trying to move, that will give you the work done. So they both look similar. Are you able to understand that point? They both look very, very, very similar. So what is the value of Q? That is going to be 2 into 10 power minus 9 into what is going to be the potential at point P? It will be 4 into 10 power 4. Answer will be 8 into 10 power minus 5 joule. Eight into 10 power minus 5 joule. Now the next question that they're asking is, this is another important point. Does the answer depend on the path along which the charge is brought? Is it answer? What is the answer for this? Does it depend on the path in which it is traversed?
No, sir.
No. Reason?
Conservative in nature.
Electrostatic forces conservative in nature. So conservative forces are path independent. Is everyone clear with this?
Yes, sir.
This one is not needed. So do this. There is a combination of electric field and potential. So electric field intensity at a point B, live due to a point charge Q kept at point A is 24 Newton per Coulomb. And electric potential at point B due to the same charge is 12 Joule per Coulomb. Calculate the distance AB and the magnitude of charge Q. So there is a charge. Due to this charge at a point P, which is at a distance R, which we don't know. Electric field at this point P is 24 Newton per Coulomb, and the potential at this point P is going to be equal to 12 Joule per Coulomb. We need to calculate the distance. Okay, this is B, no? VB. We need to calculate the distance AB. How do we do that? So electric field at B is equal to Q by 4 pi epsilon naught R square. Potential at point B is Q divided by
Sir, we can use E equal to
minus dV by dr.
S, sir.
Minus dV by dr is a potential gradient. You don't know what is the potential at this point, no? dV by dV, no, the difference in potential. It is not the exact potential at a point.
Okay, sir.
Purita. So you need to go with this thing. EB is given as 24. Divide both, okay? Divided by VB is given as 12 is equal to Q by 4 pi epsilon naught R square by Q by 4 pi epsilon naught R. So 4 pi epsilon naught, 4 pi epsilon naught, Q and Q are gone, R and R are also gone, which implies this and this will get cancelled. 2 will be equal to 1 by R, or R will be equal to half meter or 0.5 meter. So now you know 0.5 meter, take this value and substitute it here. You know that VB is 12. So 12 is equal to Q divided by 12 is equal to 9 into 10 power 9 into Q divided by R is going to be 0.5, which implies Q will be equal to 6 divided by 9 into 10 power 9. So this is 2 by 3. So 0.67 into 10 power minus 9 Coulomb is going to be the answer. Am I clear?
Sir,
Tell me.
sir, work done is Q into V, right? So, if you substitute work done as force into displacement, and force we can substitute as Q into E.
That depends on problem. No? See, it's not only about the formula, right? It depends on what context or what physics is there behind that problem. So you're saying work done is equal to force into displacement. You want to write this as Q into E into S. You want to say that E into S is V.
Yes, sir.
That depends on the concept. No? That depends on how the charge is moved and all those parameters are taken into consideration. What are the actually work done is not Fs, work done is Fs cos theta. What will you do with that cos theta?
Yes, sir. Okay, sir. Good.
Right? So the next set of problem that we are going to see will be based on the relation between electric field and potential. So we know that the electric field is defined as the negative of dV by dr. What does this negative sign here indicate? The
Increasing.
negative sign indicates that electric field is in the direction of decreasing potential. Okay. And this dV divided by dr is called as the potential gradient. I have already told this. What do you mean by gradient? Gradient is basically another name for slope. Okay. So sometimes if they give you the potential as a function of R and ask you to calculate electric field, differentiate the potential with R. If they give you electric field and ask you to calculate the potential, then V will be equal to minus integral of E vector dot dr. Okay. So I hope everybody knows this concept. Is there anyone who's not clear with this? So I'm assuming that nobody is hesitating to ask, right?
Yes, sir.
Okay. So listen to this. Find the electric field between two metal plates 3 millimeter apart connected to a battery of 12 volt. So the electric field between metal plates is constant and they are separated by distance of 3 into 10 power minus 3 meter. And the potential difference is 12 volt. Right? Potential difference is going to be 12 volt. So when the electric field is uniform, instead of dV by dr, you can use the formula V by D. That is what we do for capacitance also. So what is the value of V? It is 12 divided by D is how much? Why did I use V here? Because this 12 volt is actually not the potential, it is the potential difference. So potential difference is 12 volt divided by the distance is 3 into 10 power minus 3. So it will get cancelled. So you will have 4 into 10 power 3 Newton per Coulomb. Is that point clear? So to be more specific, right, whenever they give you the values in terms of volt and meter. Don't write it in Newton per Coulomb, write it as volt per meter. Shall I proceed?
Yes, sir.
Yes, sir.
What should we calculate? Calculate the voltage needed to balance an oil drop carrying 10 electrons when located between plates of a capacitor which are 5 millimeter apart. The mass of the oil drop is 3 into 10 power 16, 10 power minus 16 kilogram. So how to do that? So weight is going to act downwards. There will be an electrostatic force acting in the upward direction. So this should be positive. This should be negative. Okay. So mg should be equal to q into E. M is how much? 3 into 10 power minus 16 into G is, you can take it as 10, is equal to the charges. It carries 10 electrons. So 10 into 1.6 into 10 power minus 19 Coulomb into what is going to be the value of electric field? That's what we need to calculate. But I know that E is equal to V divided by D. So what can I do? In the place of E, can I replace with V by D? Can I plug in this value? So here 10 and 10 will get cancelled. See, 1.6, I am approximating it to 2 because it is 3.2. So it is going to be 2 into 10 power minus 6 into 10 power 19 is equal to V divided by D, which implies 2 into 10 power 13 is equal to V is what we need to calculate, divided by the value of D is 5 into 10 power minus 3, which implies V will be equal to 10 into 10 power 16, sorry, 10 into 10 power 10 volt. So it's minus 16, I think. So minus 16 means it will be 2 into 10 power 3. So answer should be 9. Am I clear with this? No sound at all.
Yes,
Is
sir.
it clear? Or is there any step that is not clear? Please ask me. If something is not clear, please get it clarified.
No doubt, sir.
Thank you. Do this. 1 minute time, do it fast. An infinite plane sheet of charge density 10 power minus 8 Coulomb per meter square is held in air. In this situation, how far apart are the two equipotential surfaces? You know what is an equipotential surface, right? So a surface where the potential is going to be constant or potential difference is going to be 0.
0.
Yes. So there is an infinite plane sheet of charge density. So sigma is equal to 10 power minus 8 Coulomb per meter square. It is held in air. In this situation, how far apart are the equipotential surfaces whose potential difference is 5 volt? So V is equal to 5 volt. So how do you calculate? You know that E is equal to V divided by D. Nitish, you asked me, no, why can't I use V by D, sir? Now you are able to understand why I'm directly using V by D here, because in all the problems, what is that they're mentioning?
Potential differences.
They're using the word potential difference. Had they given it as potential, I should not apply it. So yeah. So which implies D will be equal to V divided by E. What is the value of V? 5. Divided by E is sigma by 2 epsilon naught. So 5 into 2 into epsilon naught divided by sigma. So 10 into epsilon naught is 8.85 into 10 power minus 12 divided by sigma is how much? 10 power minus 8. So 8.85 into 10 power minus 4 volt.
Sir, approximately 9 millimeter.
Yeah, that's right. Is it not 90 millimeter? No, 88.5 either.
Sir, it's 10 power minus 3, sir.
Yeah, it's my mistake. It is 8.85 because I didn't multiply and I didn't change the value here. 10 power minus 3 then. So it will be 8.85 millimeter. Correct. Shall I proceed?
Yes, sir.
Yeah,
Yes, sir.
8.85 millimeter. Do this one. A spark passes in air when potential gradient at the surface of the charged conductor is 3 into 10 power 6 volt per meter. dV by dr is equal to 3 into 10 power 6 volt per meter. What must be the radius of an insulated metal sphere which can be charged to a potential of 3 into 10 power 6 before sparkling into air? So, tell me how to do this. A spark passes in air when a potential gradient at the surface of a charged conductor is 3 into 10 power 6 volt per meter. What must be the radius? So I need to find the radius so that the potential is 3 into 10 power 6. Right? So can I write dV is equal to 3 into 10 power 6 times dr? Can I integrate on both the sides? dV will be equal to V is equal to 3 into 10 power 6 into R. Right? So what is the value of V? 3 into 10 power 6 is equal to 3 into 10 power 6 into what is the value of R? Guys, tell me. It is going to be
1.
1.
1 meter. So the radius of that sphere is supposed to be 1 meter. Clear? Now, we'll do a problem based on work done. Okay, this is also an important problem. 3 points ABC lie in uniform field of 5 into 10 power 3 Newton per coulomb. Find the potential difference between the points A and C.
Sir, 0.
Why? They are not equipotential, no? Did they say they are equipotential?
Oh, okay, sir. Got it.
Sir, is the potential difference between A and C will be equal to B and C?
Okay, I would like to explain this concept. I want you all to answer this question. What is an equipotential surface?
Sir, is it 20 into 10 power 3?
20 into 10 power 3,
No, 20 into 10, 200.
200 is right. 200 is right. Now my question, if I have a surface, right, if I call a surface as an equipotential surface, then with respect to that surface, how is the electric field going to be?
Normal.
It is going to be perpendicular. So having this logic in mind, tell me if I draw a line through which 2 points, the potential will be the same.
BC.
Potential
Sir,
of
parallel to the.
yes. So can I say VB is equal to VC because they are lying along the same perpendicular to the electric field? Can I say that? So can I say VA minus VC is going to be the same as VA minus VB? Can I? So
Yes, sir.
electric field is equal to the negative of potential gradient, right? Negative of potential gradient, which implies delta V is equal to minus E times delta R. Now listen to this carefully. Minus of what is the value of E that is given? 5 into 10 power 3 into what is the value of delta R? So what is the difference between the points A and B, guys? You look at the numbers, beautiful numbers are there.
4,
3,
sir.
4, because 3, 4, 5 are Pythagorean triplets. So it is going to be 4. So answer will be how much? It is 4 centimeter, no? So it is going to be 4 into 10 power minus 2. So that will be minus 20 into 10, or it is going to be minus 200 volt. Here, what does the minus sign indicate?
Sir.
Yeah, tell me.
Sir, but they do not give VA minus VC or VC minus VA, right?
No, potential difference between A and C means generally we take VA minus VC only. Or if you write it as VA minus VC, for instance, okay, if it is minus 200 volt, then VC minus VA, you can write it as plus 200 volt. That's it. It depends on how you are going to report it.
Okay, sir.
Okay. So here, with respect to my solution, what does this delta V stand for? It stands for VA minus VC. Am I right? Oh, sorry, it is VC minus
Yes,
VA.
sir.
No. Correction. So how did I say it is VC minus VA? Sorry, I'm correcting myself, guys. This delta V, according to my solution, is VC minus VA. How did I find it out? Because I told you something important in the previous slide. What did I tell you? Electric field is in the, so E is equal to minus dV by dr. This negative sign indicates what? It is in the direction of decreasing potential. So among A and B, which one is at greater potential?
Sir, I think it's VA minus VC only, sir.
Think about it.
Sir, A is at greater potential, right?
Now then you subtract a smaller, you subtract a bigger number from a smaller number only, you will get a minus.
Okay, sir. Yes, sir. Got it, sir.
Got it. So that is why VC minus VA in the way I wrote the solution is minus 200 volt. So you reported the answer saying VA minus VC is 200 volt. Okay, this is a very, very important point. I want everybody to please make a note of it. Please make a note. If this comes in MCQ, they'll give you both minus 200 and plus 200. You'll get confused. Okay. Is everyone clear? Please give me a confirmation.
Yes, sir.
Yes, sir.
Okay. So till now we saw the problems that are based on potential work done and the relation between electric field and potential. Now we will concentrate on the concepts of electrostatic potential energy. So we know that V is equal to W divided by Q. Am I right?
Yes, sir.
One minute. V is equal to W by Q. So W will be equal to Q into V. But we know the fact that whatever work we do, right? I repeat it, whatever work we do or whatever work is done on us will always get stored in some form of energy. In this case, this work done can also be called as U, which stands for the electrostatic potential energy. Right? It's going to be electrostatic potential energy, and it is going to be equal to Q into V. Is that point clear? So that is why when you write, yesterday I told you one language, right? Like when they ask you a question, they'll say, find the force between the charges. Whereas when they ask about electric field, they'll say, find the electric field due to a system of charges at a point. Similarly, when they ask a question about potential, they'll say, calculate the potential due to a system of charges at a given point, at a point. Whereas when they use the word electrostatic potential energy, they will say, find the electrostatic potential energy between the system of charges or due to a system of charges. They'll not say find the electrostatic potential energy at a point. It doesn't make sense. Is it clear? So I'll just give you the formula, and in tomorrow's class, we'll start with the problems. Listen to this. So electrostatic potential energy of system of 2-point charges is Q1, Q2 divided by 4 pi epsilon naught into R. Okay. Due to n charges, you need to take the algebraic sum of everything. I'll not call it a scalar sum. You need to take the algebraic sum. When I say algebraic sum, you need to take the plus or minus sign also into consideration. Right. Next is potential energy of an electric dipole in uniform electric field. It is going to be minus PE into cos theta 2 minus cos theta 1, or minus P vector dot E vector. Is that clear? So these are all the formulae that we are going to apply to solve problems. And in the next class, we'll start solving the problems. Okay, so tomorrow's class, we'll discuss electrostatic potential energy and capacitors. With that, we are done with this chapter. So in the meanwhile, as I suggested, go through the videos and come, so that I need not concentrate much on the theory part.
Sir?
Please tell me.
Sir, can you show the before slide?
Previous slide, huh? Idua.
Yes, sir. 1 minute, I will note it down.
Yeah, right.
Sir, VA minus VC will be work done, right?
Idra?
VA minus potential difference will be equal to work done.
Right. Potential difference multiplied with charge is work done. No, potential difference tanda work done kadayadu. Nitish, potential difference, very potential difference. If you multiply that with charge, it becomes potential energy or work done. Purida.
Okay, sir. I got confused. Yeah.
Yeah. No problem. Okay. So if you're done, let me know. I will wind up.
Yes, sir. Thank you.
Okay. I'll see you all.
Thank you, sir.
Yeah.
Thank you, sir.
Thank you, sir.